Although the Badger is over 40 years old, its navigation systems and hull structure have been updated and strengthened to exceed American Bureau of Shipping standards. But the operation of the Badger relies on a curious mixture of old-fashioned, time-proven systems and modern, high-tech gadgetry. Coal-fired steam technology turns the Badger's massive propellers, but satellite navigation and radar guide it safely into port. The Badger boasts a safety and reliability record that is the envy of the Great Lakes shipping fleet. But exactly how does the Badger work?
The SS Badger is a steamship, and the engines that were built for the Carferry are called Skinner Uniflow engines. Each engine produces about 3,500 horsepower with a combined horsepower of 7,000. We have two propellers, each which are about 15 feet in diameter, and they turn at approximately 118 revolutions per minute. So there's a lot of power behind the Badger, probably more power than is necessary because, of course, at one time the ships were carrying up to 30 rail cars. Now we carry a fraction of the weight that these ships were originally designed for.
Got Skinner reciprocating engines. They're a good engine. They're real rugged, very well built. These ones that came out, these were built in 1951. The ship came out in 53. The steam comes from the boilers into a manifold, and it feeds both engines. Well, the pistons are connected on the piston rod, which is rigid between the two pistons. And as that moves up and down, the vertical motion is converted into rotary motion by the connecting rod. The piston moves up and down. Connecting rod is the link between the piston rod and the crankshaft, and that gives you your rotary motion.
The Badger is 410 feet long, with a beam of 60 feet. The freight bay, which once carried rail cars, but now carries automobiles, trucks, and buses, is massive. It's not quite wide enough, but it's plenty long enough for a football field to fit in its expansive interior. It's tall enough for a two-story building to fit snugly in the bay. The power plant and coal-fired boilers, the heart of the Badger, are 2 stories below the car deck. The bridge, where the captain and his crew operate, the brains of the Badger, are 3 stories above the car deck. How does the captain control this massive structure and steer it safely into harbors and around obstacles? The captain rarely steers the Badger himself, but controls the direction of the ship by issuing orders to the wheelsman. He also has no direct control over the speed and the direction that the propellers are turning. He controls them by issuing orders to the crew 5 stories below him in the engine room.
Basically, we have a communication system which is a telegraph. It's called a Chadburn, and it gets its name from the company that originally built these telegraph devices in England, and the Chadburn name stuck. That's how the captain issues his orders to the engine room. He'll ring up the orders on the Chadburns, and the engine room answers those orders. Then the engineer actually engages the engine to whatever position or direction that the captain wishes to go. If you think about it, Carferry captains make port more than any other captains on the Great Lakes. In the summer, they're doing port 4 times a day. So they become very adept at what they do.
The captain will be on the bridge at about somewhere between 15 and 20 minutes from the breakwater. He'll relieve the mate to go attend to the sea gate and getting his crew ready to come in. Max, we met earlier, is one of our lookouts. He'll be on the bow to look for small craft that may be in harm's way.
Each watch will have an engineer in charge of the watch, be it the first, second, or third. They'll have an oiler on the watch, and he keeps an eye on the machinery along with the engineer. Each watch will also have a water tender who takes care of the water to make sure the proper amount of water is carried in the boilers. You'll have a fireman and a coal passer that keep the steam up in the boilers by tending the fire. So when you make the dock, the oiler assists the chief and the watch engineer. by answering the bells and logging the counters for the revolution counter. And the chief engineer runs the port engine, and the watch engineer runs the starboard engine.
As we approach the breakwater, we put the engines on standby, and then the engineers start bringing the steam down.
We answer back standby, which signals to the pilot house that we're there and ready to answer bells.
At half to 3/4 of a mile from the breakwater, we actually check the half speed. We're bringing our speed down at this point somewhere to about 12 knots.
Full speed here is 95, so we bring it down from 95 to 75 shaft revolutions, which is the same as the revolutions on the engine.
At the breakwater, we generally try to be around 10 knots. Once we get inside of the breakwater, we'll probably bring the engines to slow, and as things keep moving down, as the speed slows us down, of course, depending on the wind, we may bring the engines to stop and actually glide in and to get our speed down in preparation of making our turn.
Depending on wind conditions and the position of the boat, the captain may use the anchor to help swing the boat around.
These boats are very maneuverable when it comes to making the turn. We get inside the piers, and depending on the direction of the wind, we'll want to stage our turn to the windward side of where we want to spin the ship.
Usually what'll happen, you'll run half astern on the coming into Ludington on the starboard, and you'll run slow ahead on the port, and that will turn the ship in the water because you're pulling back on one side and pushing ahead on the other.
As we back slow on the starboard engine, we'll see how the shape of the turn is doing for us. If it's advancing too fast for us, we'll back half. If it's not advancing enough, we may have to come ahead on the other engine. When I feel that I've got the ship in position and it's spinning at the point I want it to spin, then I'll ring off on the engine jadburns. That signals the mate in the after pilot house that he now has control or command. Then I leave and go back to the after pilot house.
Once he gets it swung around and lined up, then he'll go astern on both of them and move it up to the dock. And when he gets close to the dock, he may give it a little ahead, some slow on both to slow the ship down so you don't crash into the dock. And then once you're up to the dock, he'll go slow astern on both of them to hold you against the dock until he can get the wires out. Once he's all set and confident that it's secured, he'll ring finished with engines, and we'll shut the engines down.